Good day everyone. So for today's video, I'm going to show and discuss on how to solve the mean and the variance of the sampling distribution of the sample means. Problem. My parents, my half-sister and me weigh 74, 62, 60 and 48 kilograms respectively. Suppose sample of size 2 are drawn from this population. Determine the mean and variance of the sampling distribution of the sample means. So, our goal is to find the mean and the variance of the population and the sampling distribution of the sample means. Solution for the population. Let's first compute the mean of the population, where x is equals to 74, 62, 60, and 48, while the population is equals to 4. Formula. Mean is equals to the sum of all x divided by the population. Mean is equals to 74 plus 62 plus 60 plus 48 divided by 4. Mean is equals to 244 divided by 4. Mean is equals to 61. Hence, the mean of the population is 61. After computing the mean of the population, let's move on to computing the variance of the population. On the first column, it contains all x. X is equals to 48, 60, 62, and 74. While on the second column, contains the answers on x minus mean. You need to subtract all x minus mean, which is 61. 48 minus 61 is equals to negative 13. 60 minus 61 is equals to negative 1. 62 minus 61 is equals to 1. And 74 minus 61 is equals to 13. On the third column, it contains the answers when solving x minus mean squared. So, negative 13 squared is equals to 169, negative 1 squared is equals to 1, 1 squared is equals to 1, and 13 squared is equals to 169. On the bottom part of the third column, you can see the sum of all x minus mean squared equals 340. The formula for solving the variance of the population is equals to the sum of all x minus mean squared divided by the population. The variance of the population is equals to 340 divided by 4. The variance of the population is equals to 85. Hence, the variance of the population is equals to 85. After computing the mean and the variance of the population, let's now move on to the solution for the sample. List all possible samples and their corresponding means. In the column of samples, there are 6 pairs. The first is 48, 60, second, 48, 62, third, 48, 74, fourth, 60, 62, fifth, 60, 74, and the last pair is 62 and 74. To solve for the mean, you need to add the pairs and then divide it by 2. 48 plus 60 divided by 2 is equals to 54. 48 plus 62 divided by 2 is equals to 55. 48 plus 74 divided by 2 is equals to 61. 60 plus 62 divided by 2 is equals to 61. 60 plus 74 divided by 2 is equals to 67. 62 plus 74 divided by 2 is equals to 68. After listing all possible samples and their corresponding means, let's now construct the sampling distribution of the sample means. In the table, there are 2 columns. The first column contains the sample means, while the second column contains their probabilities. sample mean number 1, which is 54, and its probability is 1 over 6. 55, probability 1 over 6. 61, its probability is 2 over 6. 67, probability 1 over 6. And 68, probability 1 over 6. The total of all the probabilities equals to 1. After constructing the sampling distribution of the sample means, let's now compute the mean of the sampling distribution of the sample means. In this table, there are 3 columns. The first column contains the sample means, the second column contains the probability, while the third column contains the sample mean times probability. Sample mean 54 times 1 over 6 is equals to 9. 55 times 1 over 6 is equals to 9.16. 61 times 2 over 6 is equals to 20.3. 67 times 1 over 6 is equals to 11.16. 68 times 1 over 6 is equals to 11.3. In total of all probability is equals to 1, while the total of all sample mean times probability is equals to 61. In computing the mean of the sampling distribution of the sample means, the formula is equals to the mean of the sampling distribution is equals to the sum of all sample mean multiplied by its probability, which is equals to 61. So the mean of the sampling distribution of the means is 61. So, after computing the mean of the sampling distribution of the sample means, let's now compute the variance of the sampling distribution of the sample means. In this table, there are 5 columns. The first column contains the sample mean. The second column contains the probability. The third column contains the sample mean minus the mean of the sampling distribution. The fourth column contains the sample mean minus the mean of sampling distribution squared, while on the last column contains the probability multiplied by the sample mean minus the mean of sampling distribution squared. As I have already mentioned the sample mean and their probabilities, let's now move on to the third column, which contains the sample mean minus the mean of the sampling distribution of the sample means. Now remember, the mean of the sampling distribution of the sample means is equals to 61. So 54 minus 61 is equals to negative 7. 55 minus 61 is equals to negative 6. 61 minus 61 is equals to 0. 67 minus 61 is equals to 6. And 68 minus 61 is equals to 7. Now, for the fourth column, we need the answer on the third column to be squared so that we can get the answer for the fourth column. Negative 7 squared is equals to 49. Negative 6 squared is equals to 36. 0 squared is equals to 0. 6 squared is equals to 36. 7 squared is equals to 49. On the fifth column, which contains the probability times the sample mean minus the mean of the sampling distribution squared, so 1 over 6 times 49 is equals to 8.16. 1 over 6 times 36 is equals to 6. 2 over 6 times 0 is equals to 0. 1 over 6 times 36 is equals to 6. 1 over 6 times 49 is equals to 8.16. So for the total of all probability is still equals to 1, while the total of the probability times the sample mean minus the mean of the sampling distribution squared is equals to 28.32. The formula for solving the variance of the sampling distribution of the sample means is equals to the sum of all probability times the sample mean minus the mean of the sampling distribution squared. So, the sum of all probability times sample mean minus the mean of the sampling distribution squared is equals to 28.32. So, the variance of the sampling distribution is 28.32. Let us summarize what we have done by comparing the means and the variance of the population and the sampling distribution of the sample means. On the population, where n is equals to 4, the mean of the population is equals to 61, the variance of the population is equals to 85. I almost forgot. You can get the standard deviation by looking for the square root of the variance. So the square root of 85 is 9.22. So the standard deviation of the population is equals to 9.22. On the sampling distribution of the sample mean, where n is equals to 2, the mean of the sampling distribution is equals to 61. The variance of the sampling distribution is equals to 28.32. The square root of 28.32 is 5.32. So the standard deviation of the sampling distribution is equals to 5.32.